Hey everybody, this is Mr. Beckstrom, and today we're going to look at the graph of the tangent function. So here the problem says, graph the following function, show at least 2 cycles, use the graph to determine the domain and range of the function. So here we have the y is equal to the tangent of pi over 6x. So the first important thing is to know what the graph of y equals just the tangent of x looks like. Tangent of x. And in order to know that, it's pretty important to know where is the tangent of x equal to 0 and where is the tangent of x undefined at. Those are two kind of important things to know. So if we're thinking about the unit circle, I'm just going to kind of draw a makeshift unit circle here. And we know that tangent is equal to sine over cosine. Alright, so sine of x over cosine of x, right? Alright, so whenever sine of x is equal to 0 and cosine of x is equal to 1, or sine of x is equal to 0 and cosine of x is equal to -1, then this is going to equal to 0. So we're going to have an actual x-intercept on our graph there. So let's kind of draw a makeshift graph here. And where is that going to happen? Where is our sine of x equal to 0 at? Well, that's the y value, and the y value is going to equal to 0 when the graph is on our x-axis here, right? So it's going to be here at 0. So it's going to be here like at 0 and at pi. So it's going to be over here at pi. It's going to be over here at -pi, right? It's going to be over here like 2 pi, 2 pi. So these are the places where, and I'm drawing more than 2 cycles here, but I just kind of want to give you an idea what this thing looks like. So here is where the graph is going to intercept our x-axis. Why? Because these are the angles which our sine of x is going to be equal to 0, and the cosine of x will either equal 1 or -1, which means that we'll have a 0 in the numerator and a non-zero in our denominator. So we have x-intercepts at those points. Now, where is the denominator going to equal 0, which means that we're going to have undefined? Well, that is going to be whenever we're going to be pointed straight up or straight down. So that's going to be pi over 2. That's going to be, what, 3 pi over 4, right? Wait, hold on. Is that, let me see, that's pi over 2, 2 pi over 2, 3 pi over 2, excuse me, 3 pi over 2, 5 pi over 2, 6 pi, 7 pi over 2. So that's going to be right in the middle of these angles here. We're going to have these, excuse the horrible vertical asymptotes, but right in the middle of these we're going to have vertical asymptotes. So I'm going to kind of draw these right in the middle of these intercepts. We're going to have these vertical asymptotes. So here's the intercepts. We have these vertical asymptotes in the middle. The only thing we really need to do is see which way they approach once they kind of leave these intercepts here. And to do that, we can just probably put in values and see whether it's getting closer to positive infinity or negative infinity. So let's just kind of do that with one of them. Let's use our calculator. So let's do it with, let's go ahead and go to y equals, and let's do the tangent function. So I'm going to go ahead and put the tangent of x in here, and go to second window. So my table set, make sure I'm on ASCII Auto, and I'm going to go to second graph. Here's my table. Delete this out here. That was from something else. And I'm going to put in values Well, I know if I put in a 0, I should get a 0, right? Because I know it intersects right there. And I'm going to put in something that's a little bit less than pi over 2. So I'm going to say second pi over 2, pi divided by 2, and I'm going to say minus like 0.1, right? Just something a little bit less than pi over 2. And notice that I get a positive value. So that's going to be like somewhere up there, right? Now let's put in something second pi over 2, pi divided by 2, minus something even closer to pi over 2. How about minus 0.001? And notice that's 1,000. That's a y value of 1,000. So that's way up there. So this thing, as it's approaching that asymptote, it's getting really close. Now let's do something close to negative pi over 2. So I'm going to do second, oops, let me clear that out. If I do negative second pi divided by 2, so that's negative pi over 2. Now I want to add a little bit because I'm going to be on the right side of that. So plus 0.01. And notice I get negative 100. So as I'm going this way, I'm going down like this. And if I check on both sides here, I'm going to notice that it's just going to do the same thing here. It's going to go like this. It's going to go like this. And it's going to do this. That was a bad one here. And it's just going to repeat this on both sides. It's going to repeat this. And I know that drawing by hand doesn't look good, but infinitely. And so what is the period? The period is the distance, the x value distance that it takes for one of these things to make a full cycle. So it's making a full cycle from negative pi over 2 to positive pi over 2. And that's a distance of pi. So the period of the y equals tangent of x is just pi, because it does a full cycle from negative pi over 2 to pi over 2, or from pi over 2 to 3 pi over 2. So it takes a full pi for this to make a complete cycle. All right, and let's go ahead and actually just go, we have tangent in there. Let's look at the graph. And sure enough, it's a much nicer version to the one that I tried to draw by hand, but as you can see, it looks pretty much the same. If I were to put a trace right there, if I were to put a trace right, let me see if I can move over. How do I jump over to the next one? I thought I could. There we go. If I put a trace right here, this point right here should be very close to pi, and as you can see, if I do that, that should be very close to 3.14, which it is. If I go to the next one, that should be very close to 3.28. Let's just look at that. Might be able to have a hard time seeing on the video, but excuse me, 3.14, 6.28. Yep, which it is. All right. So how does this constant pi over 6 multiplied by our angle x affect this graph? How does it, what transformation does that make? So great question, and it does. It affects our period in the following way. So the period of our tangent function, or our tangent graph, is equal to, remember for the sine and cosine, it was 2 pi over, we did b, but the book uses w, so let's go ahead and, or omega, but it looks like a w. We'll go ahead and use omega for this one as well. This is going to be, instead of 2 pi, it's just pi over omega. Pi over omega, where in the form y equals a times the tan of omega x, like this. All right, so in this form here, the period is equal to pi over omega pi over omega there. So in this case, our period is equal to pi divided by pi over 6, and that would be equal to pi times 6 over pi. Pi's cancel out, and I'm just left with 6. So this thing is going to get stretched. It's going to get stretched. So our total period is going to be 6, which instead of going from what, negative pi over 2 to pi over 2, this thing is going to go from like negative 3 to positive 3, because it's going to go a total distance of 6. So if I were to graph this, I should see those intersects at negative 3 and positive 3, and let's check to make sure that that's true. So if I go here, and we're going to do tangent of pi over 6, so I'm going to do second pi over 6 x, close parentheses, enter, and let's graph this, and trace. Pi over 6. All right. No. Hold on just a moment. All right. So it looks like our period is 6, which means that instead of going from yeah, that's right. I was actually looking at the vertical asymptotes, and here I was looking at the intercepts. Right. So here the intercepts go from 0 to pi, which is a distance of pi, and here they go from 0 to 6, which is a distance of 6. So here they don't show the asymptotes there. So this is correct. All right. I hope this helps. If you all have any questions, please let me know, and hope you all have a great week. Thanks.